Hello everybody and welcome to another exciting edition of Mr. Duncan Teaches Us Math by Video. I must start with a confession today. Math teachers sometimes lie to us. I know this is nothing new to you guys, but let me clarify that a little bit. What I mean to say is that sometimes math teachers make things seem more simple than they are in order to teach a particular concept. Today is one of those lessons where we try to undo a little bit of that. We've been talking a lot about linear equations. Linear equations are where everything looks pretty, and when you graph it, you have a single straight line and all the dots line up. Clearly, as you can see on the graph on page 1, slide 1, that's not the case in this picture right here. We have an example of a graph right here where we are graphing car weight versus miles per gallon. Okay? And clearly, as you can see, we've taken a lot of data and they don't all line up. However, what they do is give us a basic understanding of what happens as car weight increases, our miles per gallon decrease. We do not have a single straight line, but what we do have is kind of a guess that it's going to go something like this if we were to try to fit all of this data into a single straight line. Now, does all of it fit there? No, this stuff out here doesn't quite fit, but as a general rule, we can represent our model of miles per gallon versus car weight by a line that looks something like what I've just drawn right here. I want you to pause and try to summarize what I have just said in your own words, and then continue as we go on to the next slide. Go ahead, pause right now. I'll wait. Okay, welcome back. We've moved on. I have another problem that I have a lot of data here, and there's already a guess line drawn for us. This one is study time in minutes compared to test score. Okay? Clearly, as it makes sense, the more you study, the higher your test score. And as I'm going right and up at the same time, I end up going on a diagonal up and right. Okay? So we've got every one of these points here is going to represent some student's experience. So this student right here has studied for about 8 minutes, 7 minutes, 8 minutes, and got about a 65 on their test. This student over here studied for about 36 minutes or so and got an 85 or thereabouts. Okay? And every one of these little X's is a different student. They don't all show exactly a linear pattern, but what we can do is we can take all of the points and kind of make a guess line through it. This is called scatter plots and trend lines. So I want you to write down these definitions. Okay? The first one, scatter plots, means a graph of discrete, that's having only unconnected points, data. So this is all a bunch of unconnected data points, and that's what a scatter plot is, when we graph a whole bunch of points. Okay? Often we make scatter plots to look for patterns, as we're doing in this lesson. Next, a trend line. So that a scatter plot is what you see here with the actual graph and all of our dots. Okay, there's dots everywhere. The trend line is what you see here in red. That's this thing right here. The trend line is what we call a line of best fit. This is the best line we can draw to approximate our data. We normally want roughly the same number of data points on one side of the line as on the other. Now, what does that mean? That means if you draw this line, if you notice the points up here, there's about the same number of them as there are below on the other side of the line. And that's how we generally try to pick a line of best fit. We want about the same number of points above as below. Okay? So go ahead and copy down those definitions, and then we're going to move on. All right. If you're still copying, you can pause the video for a second. I'm going to move on. The table below shows the times that several students studied for a final exam and the resulting scores that they received. Make a scatter plot of the data and then use it to draw a line of best fit. Okay, so first thing I need to know is my time. Time is always going to be my independent variable that is on the x-axis. And I should probably do this in a permanent pen. So time is going to go there. And on the y-axis, I have my score. And I need to figure out what scale, what numbers do I need to fit on this graph to know what scale to make. Looks like my hours are going to go up to 12. Excuse me. So what I'm going to do, I'm just going to count by twos. 2, 4, 6, 8, 10, 12, and I'll go up to 14. Okay. And then on the y-axis, I need to go all the way from 10 to 53. So I'm going to count by, I'll count by tens. It's not going to give us great data, but no, you know what? I'm not. I'm going to count, I'll count by sevens. I'm a math teacher, so I know my 7 times table. 7, 14, 21, 28, 35, 42, 49, 56. Okay, and that will cover everything, so I'm just going to stop there. Now I need to graph my data. I'm going to graph this first point, 1, 10. So I go over 1 on the time and up to 10. That's going to be right about here. Okay. The next one, you know what I'm going to do? I'm going to just create myself a little dot because I can do that clearer than I can do anything else. Fills up green. Okay, and then I'm going to infinite clone it. Okay, so the first point's going to be somewhere right about there. The next point is going to be at 2:12. So I go over to 2 hours. Somebody who studied for 2 hours got a score of 12. That's going to be right about there. All right, next I have the point 4, 19. So someone who studied for 4 hours got a score of 19. If anybody's thinking that these are really awfully big times to be studying, you're wrong, first of all. But maybe we're talking about a college class. Who knows? Okay, we go over to 5 hours, and we have 29. So 5 hours is a big jump, goes up to about 29. That's right about there. 7, somebody who studied for 7 hours got 32. So I'll go over to 7, and then up to 32. That's right about there. Someone who studied for 8 hours got a 35. So 8, 35. That's right about there. Someone who studied for 9 hours got a 41. About there. Someone who studied for 11 hours got a 47. Right about there. And someone who studied for 12 hours got a 53. Do these points all line up? Absolutely not. But do they kind of give us a general trend? Sure they do. So what I'm going to do, I'm going to grab a line. I'll do it also in green. And I'm just going to try my best to fit this line such that there are about an equal number of points above as below my line. Right about there is what I would say. Yours is going to look probably a little different when you draw it, but that's all right. It needs to be about like what you see here. Okay, and then what I'm going to do, because I know what's coming next, I'm going to copy all of this. And I'm going to put it onto the next page. And then I'm going to shrink it way down. Because we're going to need it to answer these questions. This was the whole reason we do math, is to answer questions about the situation that we just found. The first one says to give the equation for the line of best fit. Well, what we're going to do here is we are just going to look at our line, and we're going to use our easiest form, which is y equals mx plus b, which means I need 2 pieces of information. I need my slope and my y-intercept. The y-intercept is really easy to find. In fact, you know what I'm going to do? I'm going to move this down. Oops. I'm going to move this down just a little bit so I can make it a lot bigger so that you guys can see what it is I'm talking about here. Okay. So I want my line of my my y-intercept. It looks like the y-intercept is going to be somewhere right about here. Okay, that to me, let's see if we can blow it up just a little bit. That looks like maybe it's going to hit just a hair under the 7. So maybe say 5. My y-intercept is probably going to be something like 5. Okay, so I'm going to bring this back up, and I'm going to say my y-intercept is 5, and so I'm going to draw this in y equals mx plus 5. Now I need to figure out what my slope is, and I have my equation. Well, let's look down here again. Let's see. Let's try to find 2 points that roughly land on grid marks. This one right here lands pretty close to that grid mark, and this one right here lands pretty close to that grid mark. So all I need to do is figure out what my rise and my run is between those 2 points. Well, the rise goes from 14 to 28. So 14 to 28, my rise is 14. I'm going up 14, and then I go over between those 2 points. Let's see, between here and here, I'm going over between 2 hours to 6 hours, so that's over 4 hours. I go up 14, over 4. They're both in the positive direction, so my slope is my rise over my run, 14 over 4. Now I'm going to shrink all this back down, so it's not in our way anymore. And I'm going to erase this because I no longer need it. My slope is 14 over 4, but that's not quite in simplest form, so I'm just going to reduce that to simplest form 7 over 2 by dividing top and bottom, numerator and denominator, by 2. So I have 7 over 2 as my slope, and so my equation, y equals mx plus b, is y equals 7 over 2 x plus 5. That is my equation for my line of best fit. Now let's see if I can do what I want to do here. Do that. Okay, and then I'm going to try to group all of this stuff, shrink it down so it's not right on top of the next question, which is, what is the meaning of the slope? This is a question that is often difficult for students. The slope represents your change, your vertical change divided by your horizontal change. So how much I go up divided by how much I go over. So when it says that I go up 7 and over 2, think about what your up and your over mean. Up is an increase in your score. Over is an increase in your time. Okay, so when I'm going to the right, my time is increasing. When I'm going up, my score is increasing. So 7 over 2, let's do this with a permanent pen. 7 over 2 means my score goes up 7 every time I increase my study time by 2. Okay, so that's what the slope means here. It means according to my line of best fit, I get 7 points higher on my test for every 2 hours I spend studying. Okay, so the way that you answer questions like that in the future, think about what the rise and the run actually mean. What does an increase in your y-axis mean? What does an increase in your x-axis mean? Okay, now we're going to do a couple more questions and then we're done. What is the meaning of the y-intercept? Again, think about what the y-intercept means. It is the point, let's see if I can blow this up just a little bit. It is the point where your line crosses the y-axis. Okay? It looks like it, as we have guessed it to be, it's about 5. Now, what is it that you know about the y-intercept? Well, you know that you always have an x value of 0 at the y-intercept. So what does that mean in terms of our graph? An x value of 0 means you have spent 0 time studying. And a y-intercept of 5 means that you get a score of 5. So this means that you get 5 points for not studying. Okay? That's what you would expect, what score you would expect to get for studying 0 amount of time. I do not recommend that, certainly not in college. Trust me, I've tried it. They make you repeat the course again, and you have to pay for each one. Okay, make a prediction about what grade someone who studies for 11.42 hours might get. Let me be very clear here. When we say make a prediction in math, we do not mean guess. We mean make it means we make an educated guess. We want something that's going to be close to accurate. So what I'm going to do, as you might have guessed, I'm going to go back, I'm going to grab the equation that I've made, y equals 7/2 x plus 5, and I'm going to use that to make future guesses. Okay? So y equals 7/2 x plus 5. Now, which piece of information do I know? Do I know my x, which is my time, or do I know my score, which is my y? Well, I know my time, so that's x. So what I'm going to do is say y equals 7/2 times 11.42 plus 5. Now, guess what I'm going to do now? I'm going to cheat. I'm going to use the calculator, and I'm going to get 7/2 times 11.42, and I get that to be 39.97. Add 5, and we get 44.97. Y is approximately equal to 44.97. Approximately, because remember, our model is a guess. Okay? We don't know for certain that somebody's going to get 44.97 points, but that's what our model would suggest. And so what I'm going to do here, I'm going to say y is approximately 45 points. That's about what we would expect from 11.42 hours of studying. Some of you are probably saying to yourself, wow, that's a lot of studying for such a poor grade. Nobody ever said it was out of 100 points. And also, maybe we're in med school and we need to study 13 hours to get a passing grade. Who knows? Number 5, make a prediction about how long someone might have studied who got a grade of 62.5. I'm going to do the exact same thing and then be done. Y equals 7/2 x plus 5, except now I don't have my time, I have my grade. 62.5 is equal to 7/2 times x minus 5. All I need to do is solve for x and I'm done. So I'm going to add 5 to both sides. 67.5 equals 7/2 x. And then what I'm going to do is on both sides, I'm going to multiply by the reciprocal, 2/7. Those are going to reduce to 1. Those are going to reduce to 1. And then I'm going to do the same thing, times 2/7. I'm going to use the calculator to help me there again. So 67.5 times 2, and then divided by 7, gives me x is approximately 19.29 hours. And I will just leave it like that. It went a lot higher. I just rounded 19.29. In fact, let's just round to 19.3 hours. Okay, that's what we've got. We will be doing some work like this in class, but this is a good introduction to that. All right, thanks so much for watching. Enjoy your evening.